what is DNA, right? What is the data type that drives Ellie? Specifically speaking, how does that data type differ from just a generic data type that you would normally use? And why is it important to building the technology that we're currently building? I think our approach of environment first and behavior driven learning instead of the classic request driven learning where it's you request something and then immediately it gives back a response. Instead, we're thinking, all right, you go about your day, and then as you're behaving, this kind of system periodically checks in and refines a model that's based on how you behave. Ellie utilizes environmental factors to justify events and different actions that can occur. So, whether it's sound or you walking or vibration analysis, or it might be as simple as hearing a dog bark, there's always some kind of capturing happening, which then allows the model to kind of learn from the environment. So this gives us more of the behavior first approach where we don't necessarily request something first, but we allow the behavior to occur. And then once the behavior occurs, then the request can be fulfilled, but it's not a request in per se you ask it to do something. It's more like your actions, your behavior in itself is the request. And over time, our learning model will decide and learn how your behaviors affect the environment and also affect ways that the environment are going to either treat the situation or build a context. Now, I want to speak specifically about context building. What does that look like for Ellie, right? So context building is a really interesting type of aspect of AGI that I believe is probably more fundamental than the actual output, right? Building context and making sure that context is correct is one of the hardest aspects of building AGI, right? You can request something, it can compile an LLM or compile a language model and spit out some sentences, right? But being able to decide and infer the right action or the right quality of action to give you as a representation of the context in an environment specifically behavioral driven is really difficult. This type of model isn't easy to build. And in order to build a model like this, we need to kind of create new semantics and create new language around how we describe AI, right? One of the things I propose is I like to call it a syntactic sugar. This type of sugar that I'm speaking about is not necessarily a mathematical object or a way of doing learning, but it's more of a way of organization. It's like when you have a biological system and you have a kingdom and a phylum, you know, those things are organized in specific ways, which allow people who study that ecosystem or the type of species to understand a better lineage of where things came from. I propose that we do something similar for Ellie, right? Or one of the aspects that we utilize is we approach AGI by first labeling and understanding how to organize different inputs into context, right? Now, the way that Ellie works specifically is mostly through sound. And because we're doing mostly sound recognition, our bedrock of our technology is we want it to be in the background. We don't want it to be in the forefront. And again, going back to the analogy of kingdoms and phylums and organization and biological systems, the same thing can be said about Ellie. So our approach is simply that we create a syntactic sugar, was what I was talking about earlier, which is not a mathematical object, but more of a way of discussing or labeling context, right? So we developed a new data type we like to call DNA. Just like DNA in a biological system, it acts very similarly in that it creates kind of these signatures which identify different objects and different things in an environment. One example of this, which I've mentioned in my previous video, a similar example is like an animal, right? So you might have a recording of a dog, and a large language model might be able to discern a sound that is a dog, but can it discern Henry the dog or your dog or its favorite squeak toy that it likes? Can it identify the actual toy itself, or can it identify a toy, right? So again, it's not about learning about what a squeak toy is. It's about learning what a squeak toy is relative to its environment and also to other things around it, right? So if a dog loves a squeak toy, that specific squeak or that toy can be recognized by that dog specifically, right? So those unique entropic kind of data points for that specific squeak toy is going to be different than another squeak toy that was produced in the same way, right? So two of the same squeak toys are never going to sound exactly the same. To a human, that might not be true, but to a computer, absolutely. And so that's where the syntactic sugar comes into play, right? So we label it with a unique kind of property or unique label that allows that squeak toy to be associated with that dog in the environment. And we use sound. What's interesting about sound that I really like is that sound can be recorded over and over again, and every time it's just slightly different, but overall the same. And it's really, really low power, and it's really easy to gather. It allows elle specifically, elle doesn't have to take in sound, right? It just happens to be that sound is the easiest way to produce labeling in a real-time environment. If you try to do this with cameras, any kind of other technology, it's too much power. And power really is the key here. The amount of power it requires is way too much. With sound, you can do the same thing with a camera where it's in passive mode. If you have a sound engine similar to elle, engine itself doesn't require sound. It's just that sound happens to be the easiest modality to capture the most entropy in the environment to build a context. In other words, if you have two of the same exact sounds, they're never going to be the same. And so if you repeat a sound over and over again, you're reinforcing that sound and you're labeling it the same thing because they're similar. And therefore, the more of that specific sound you have, the better the labeling it gets and the more broader spectrum of that sound you can capture. Like I said, elle doesn't require that you use sound to process data, but it just happens to be the easiest way to capture the most environmental data. Speaking about DNA, so DNA is our own unique data type, and it is unique to elle, so elle is the only one that can read it, which makes DNA very secure. And what DNA allows us to do is it allows us to basically modify the structure of a sound or a signal and remodify it and sample it over and over again, thus providing a unique authentication model for that specific sound or context. Now imagine having multiple sounds in one scenario and being able to discern all of those different sounds embedded inside of one sound file. So being able to build context from a sound file is very important, and being able to separate those different sounds and be able to label them individually. And then once we label them, rebuild that sound and have a unique signature for that environment, so that if it hears that sound again, or if it encounters that specific environment again, or that specific individual within that environment, then it's able to respond accordingly. And because sound is everywhere, it allows elle to constantly be capturing those sound. I believe that elle is an important aspect of the next generation of computing, because we need to start building these data types for computers and for other devices to connect to. I see that like there's this future that we can have where, we have this data type that's kind of seamless through specific devices and specific areas and contexts. Like imagine being at a concert or in a car or at a park. There's specific things that you want to happen, that you want to occur, that typically should occur for everybody, right? And then there's specific things that you want to happen just for you, right? Maybe your favorite song should be played, or maybe you don't want to forget something when you leave the house, right? Those are things that are specific to the user. However, most people can benefit from those functionalities. Well, one of the aspects of elle that I really like is that we're not trying to build functionality into elle. We're trying to let elle decide what the functionality should be. And yes, will we build physical functionality through programming? Of course, because you have to, because the part of building functionality for any model is being able to show it what it can do, right? However, the ease of connecting to functionality is kind of what elle is supposed to be about, right? I'm not trying to build a technology that's a fad. I'm trying to build something more fundamental than that. I'm trying to assess the landscape of technology and build a new type of model or a new type of system that fundamentally changes the way that we compute with the rest of the world, right? I want users and environments to build context which drives technology and therefore drives situation. In the next few weeks, I'm going to start revealing some very specific features that Ellie is going to have, including some snippets of first look at Ellie and kind of what we've been working on for the past 4 years and what we think the next era of technology is going to be. I really believe that Ellie is at the forefront of tackling the next generation of technology in a way that is not only intelligent but smart and allows it to grow independently of any outside influence. I want to be very clear and say that we are not here to collect data. We are here to build a system that can intelligently help society and help the next wave of technology adjust itself. That is fundamentally what AGI is about. I think that artificial general intelligence is very important in the next era of technology, and recalibrating AGI is the next big breakthrough in AI. And I think us being able to lay down the foundation, lay down the groundwork for other individuals to build on top of is really important. For me, it's not just a technology. I want to build something that is unique and that the world can benefit from. I'll end with this, I guess. Ellie is the single most important thing I will ever do in my entire life. And because of that, I'm going to work on it as hard as I possibly can. And I'm going to make very, very hard strides to create great breakthroughs as much as I can. And the more support you can give me and the more support that you can give Ellie, the better. This isn't a egotistical endeavor. I'm not trying to get rich quick. I've spent 4 years researching this topic and understanding it and developing it, and I'm finally at a point where I'm able to start releasing tidbits and start talking about the things that we've been working on. And it's incredible what we've come up with and what we've been planning for the last 4 years and what we've researched and uncovered and what we thought we knew and what we don't know. These things just keep getting more and more in depth. Everything is just way more cumbersome and way bigger than we thought it could ever be. And I'm here to build that technology. I'm here to make sure that technology exists in this world before I die. It seems to be that the next phase of this of technology in general, the next era of technology, is not going to be a request first approach. It's going to be an environment first approach. So a individual driven, community built engine is what is required for the next era of technology. And you can mark my words, but I'm saying this with very, 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 very clear intentions that the next wave of technology will come from a environment first approach. I want to thank you for watching and thank you for your support. And I will keep you guys posted with more updates with Ellie.